Hello, mathematical here to explain the derivation of the sine function. Disclaimer that I skip some steps in working out, and so if you feel free to pause the video if you need to, in case you're both not lightning fast at maths and maybe you don't trust my working. But anyway, I'm sure many of you have seen a unit circle, and you know that the y-coordinate is equal to sine x, and that the x-coordinate is equal to cosine x. Sorry, theta, sine theta and cosine theta. But if for a long time you've puzzled about how they actually work out the length of this side based on this angle and the hypotenuse being 1, then you're definitely not alone. And since I've worked it out now, I'd like to explain it in the easiest way possible. So, we'll just draw a rough sketch of a sine wave, because we know it will be something like this. We don't know the exact values, but it seems obvious that it is a polynomial with infinite terms and with infinite intercepts and infinite turning points. Therefore, it will have infinite terms, each one smaller than the last. The cosine wave is the red line here, and you may have noticed that each turning point on one happens to be the intercept of the other. So that indicates that, and just from any point, it would look like the red line is equal to the gradient of the blue line. So for example, at the peak, when the blue line's gradient is 0, the red value is 0. We can prove this through geometry. And so consider this half a unit circle with a tangent. The tangent, so a unit circle has the following function. Since it is often known as 1 is equal to x squared plus y squared, it's better to make the function axis the subject. A line passing through the origin and a point on the unit circle would have a gradient of function x over x, meaning function of the unit circle. So that's the gradient. A line that's tangent to the unit circle, which for those that don't know means that it touches it at one point only, would be perpendicular to a line passing through the origin. Therefore, it would have the negative reciprocal gradient. So you know that on the unit circle, any point on the unit circle, the amount it's going up is this value, and the amount every time it goes horizontally 1 unit. We can have this relationship, this ratio, that the vertical position to the horizontal position is, the vertical speed to the horizontal speed is negative x over square root of 1 minus x squared to 1. And so let's say something is moving around the unit circle with a net speed of 1. So this ratio is true, and to calculate the net speed, you can use Pythagoras' theorem, subbing the vertical speed and horizontal speed, and it gives this value. But didn't we say that the net speed was 1? We left the ratio we've got, so that the last term is 1. And what do you know? Now there's negative x. So therefore, this would be saying that if the net speed of something going around a unit circle is 1, then the vertical speed is equal to the negative horizontal position. But since every term had a surd in it to begin with, we must do plus or minus. And since logically we must go with plus, because it's obvious that when when something is on the left of the unit on the right of the unit circle with a positive x coordinate, it's moving up. So therefore the vertical speed is x, not negative x. This means differentials is about the rate of change of a function. So if the differential, this proves that the differential of sine x is cosine x shifted a quarter, so differentiating it shifts at a quarter phase. Therefore it's logical that it will continue shifting at a quarter phase. And therefore the intercept cycle will go 0, 1, 0, 1. Sorry, 0, 1, 0, negative 1. So vertical velocity is horizontal position, and so we can look at the unit circle from any angle really, and say horizontal velocity is negative vertical position, negative vertical velocity is negative horizontal position, negative horizontal velocity is vertical position, and then, yeah, so it's a repeating cycle. And we know that the intercepts will be 0, 1, 0, negative 1, 0, 1, 0, negative 1. This is changed by differentiating. So therefore, the constant of each term, so the first term of the Taylor series will have to be 0 because that's the constant, the intercept. The second term will have to be x because for the cosine wave, once it's differentiated, x will become 1, so that gives the intercept of 1. Third term, so for the second differential, it will be, second derivative, it will be negative sine and have an intercept of 0 again, so 0 differentiates as many times as you want and still stays 0. The fourth term will have to be x cubed, negative x cubed on 3 factorial, because if you differentiate that three times, it becomes negative 1, so for the negative cosine, and then so 0 again, and then this time it's the fifth integral of 1, so yeah, therefore we know the pattern, we can follow the pattern and know that, so you start with x, then to get the next term you integrate, and negate. So if we do that, x plus x, but the last term, integrate, negate, new term, integrate, negate. And if we keep doing this, with an infinitely long series of terms, it goes like this. And since cosine is the derivative of sine, this is the Taylor series for cosine. And when I plot that on a graphing calculator, this is the beautiful part where the maths does itself. It naturally cuts the x-axis at x is equal to 3.14159, so on. And so since we know that, when we think about it, the x-axis is time and the y-axis is vertical position. So therefore we know that since the speed is 1, after 3.14 seconds, or units of time, it completes half the circle. We know that with a radius of 1, half the circle perimeter is 3.14159 units of distance. And also, I programmed a sine calculator on Python. If you want to copy this code, you can. It builds the Taylor series algorithmically, just like I demonstrated. If you want to make it more accurate, then you can increase this number, but it's still pretty good because it's 50 terms. As long as you're in the first phase, it should be pretty accurate. Oh, and also you'll need the factorial function to put in it as well. So anyway, that's how sine works. I hope this helped. You can now solve trigonometric problems without a calculator, but just remember it's in radians. Anyway, bye.